person, little jumpsuit wearing sequins. Well, it's time to stop your midnight driving and put your dancing shoes away. A little woman, little man, little grown-up, little platform wearing disco fan. It's time to stop your late night shaking. It's the end of a long dancing day. This is a disco. This is a disco lullaby. Lay down your funky head. It's time to go to sleep now. Go get tucked into bed. Your daddy and your mommy will boogie shake their bunnies at the disco scene. But first they'll tuck you into bed and you'll disco in your dreams. Disco dreams. Oh, little boy, little girl, little person, little jumpsuit wearing sequins. Well, it's time to stop your midnight jiving and put your dancing shoes away. A little woman, little man, little grown-up, little platform wearing disco fan. It's time to stop your late night shaking. It's the end of a long dancing day. This is a disco. This is a disco lullaby. Lay down your funky head. It's time to go to sleep now. Go get tucked into bed. Your daddy and your mommy will boogie shake their bunnies at the disco scene. But first they'll tuck you into bed and you'll disco in your dreams. Disco dreams. 3, 2, 1, let's jam! Come on, it's Friday. It's that time of the moon. It's that third Friday that can never come too soon. We'll hear about science, or maybe some art, or maybe some weird hobby close to somebody's heart. It's Nerd Night. Get your nerd on. In Tokyo. Keep your shirt on. Ryozard. We'll make you think now. Park Lounge. Buy a drink now. We're here, and it's time to begin. Pay your money to Selena and get yourself in to a chair and maybe a drink. Who knows? Our topics tonight may be your special kink. It's Nerd Night. Get your nerd on. In Tokyo. Keep your shirt on. Ryozard. We'll make you think now. Park Lounge. Buy a drink now. Hey, 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 who's here?
It's Roots, he books all the speakers. Talk to him if you wanna buy a beaker.
Only a couple left.
It's Melvin, he's manning the lenses. He makes sure we can welcome all our online friends. It's Coco making sure things stay on track. When all the shit goes down, she's always got our backs. It's Selena, hubba dubba dubba ding. Hey, look at that, I can scat, that's my new thing.
Sheba-boo-bap.
It's Daria, she's running the sound. If you can hear us, it's because she's around. It's Travis, he's running the stream. And he's the second newest member of the Nerd Nite team. It's Gray, they're new and they're kind. They rescued our soundboard when we left it behind. It's Andrew, he's emceeing the show. And he's got no pants on, as if you didn't know. It's Nerd Night.
Get your nerd on.
In Tokyo.
Keep your shirt on.
Ryozard.
We'll make you think now.
Park Lounge.
Buy a drink now.
It's Nerd Night.
Get your nerd on.
In Tokyo.
Keep your shirt on.
Ryozard.
We'll make you think now.
Park Lounge.
Buy a drink now.
Here we go.
All right. This is very short. Hello? Is mic 1 even plugged in? I saw 3 things plugged in. Maybe it's on. I think give me mic number 2. I'm pretty sure mic number 2. What numbers are plugged in there? Ha 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 ha. Bop bop. Look, I can see the lights. Look at the lights. Bop bop bop. Huh? There we go. Now we're on. Okay. All right. Give me a bit more. Give me some juice. Use the gain. Gain. Oh, wait, a little bit less. Okay, good. There we go. We got that figured. I'm not gonna put that. Yeah. In a second, I'll be Freddie Mercurying this thing. All right. Sorry, this has gone upside down. Okay, there we go. All right, welcome to Nerd Nite number 67, Rockets and Reality. Okay, I have... Oh, and my phone screen just went completely off. Okay, it's back. All right, my next note says The Place. I guess I was mid-thought when I got interrupted on that. Oops. Yeah. Okay. I guess that wasn't important. The Place. Tonight's music and trailer song are, I mean, the lyrics are by me, but the song is by an algorithm. It's a market improvement, I gotta say, over the last time. I only had to do, like, burn down one rainforest to make tonight's song. It's really hard not to play with this toy. I'm very happy to switch back to real music if someone can find me something that doesn't sound like stock YouTube crap. That would be great. Nerd Nite, by the way, is the local franchise, our local franchise, of a global speaking event. This is our Nerd Nite. There are many like it, but this one is ours. There are many Nerd Nites all over the world, including 3 other ones in Japan. Can I remember? Kansai, Fukuoka, and Okinawa. Every month, we host 2 speakers who scroll up, who talk about their field of expertise. Now, this can be anything. This can be science communication. This can be art, humanities, activism, weird hobbies, anything. That's nerdy. Yeah, it's got to be pretty nerdy. I had actually one guy refused to give a talk because he didn't want to be identified as a nerd. And it's funny because he's the nerdiest guy I've ever met in my life. Help us out by following us on social media, talking about us there, retweeting our posts, tagging us in posts about interesting stuff. Public service announcement, I do this every time. Please use Firefox. It's the only browser that's not owned by a billionaire that's actually like an official browser that's supported by governments. The problem is if it falls below 2% usage, and it's very close to doing so, it will stop being supported by the US government, which will basically make it useless. Well, yeah, that might happen anyway. Yeah. Anyway, Mozilla, not perfect, but at least they're a nonprofit and they're not owned by a billionaire. Bruce probably uses line mode browser on an IBM 3270. But for the rest of you, Firefox. That was a deep cut for terminal nerds. We're all about deep cuts here at Nerd Nite. That's kind of our deal. Anyway, yeah. So Firefox plus ad nauseum to get rid of ads, and also then feed the ad companies bogus information. Mwah, chef's kiss. Anyway, and I mentioned last month they got translation, inline translation working in March, and it has some kinks, but it breaks Japanese websites way less than Chrome's auto translation. So there's that. My only reason to use Chrome is basically gone. I'm so deep into Google's ecosystem. I'm trying to back myself out piece by piece. I'm trying to self-host stuff. Anyway, I'm going into a huge thing. Anyway, point is, let's move off of billionaire-owned platforms and use Firefox, maybe, and Mastodon. Famichiki server, very on point. All right. I'm holding this. The reason I had the stand... Oh, mother... Sorry for the clicking people on the live stream, and it just popped right out. Will it work? Are you on that screen? You're great. Thank you. Our next event is, why do I need to look at this? I've got it right up there. It's May 23rd. Is it getting shorter or is it just me? Hold on. There, human height. Okay, May 23rd, and we're back here. So, cool. Other big events that have happened on May 23rd. In 1516, the Munich Freiheitsgebot took effect in all of Bavaria. This limited This is relevant. This limited the ingredients that could go into beer to barley, hops, and water. This was, of course, less about food safety than just making sure that bread was available, because people were using rye and wheat to make beer, and that was making bread more expensive. In 1635, the first public school in the United States, the Boston Latin School, was founded on that date. This is significant because we may be seeing the last public school within our lifetimes. 1967, Soviet space program, Soyuz 1, crewed space flight carrying cosmonaut Colonel, wow, Vladimir Komarov is launched into orbit. It's a nerdy. 1985, on May 23rd, Coca-Cola changed its formula and released new Coke. That went well. 2005, the first YouTube video entitled Me at the Zoo was published. That also went well. Nothing horrible ever happened. Nerd Nite Tokyo is exactly like these, except without the horrible consequences, I hope. Anyway, our host is Ryozen Park's Lounge in cozy Sugamo, where the average age of residents is actually not a bad IQ score. By the way, if you want to speak at a future event, it took a minute. If you want to speak at a future event, contact a team member, specifically that team member in the mask over there, who we call American Andrew or Bruce, whichever is less confusing or more confusing. Drinks, please buy drinks. We don't have any beakers tonight, by the way. I'm sorry. That's the one thing I forgot today. There's only 2 left, and they're in 2 different places, and I didn't pack them. But we had one last time. This time we have none. But I'll bring them next time. So if you want beaker, next time may be your last chance. Buy drinks. Thanks, Ryozan Park Lounge. That sounded sarcastic. I didn't mean it that way. Call for volunteers. We need cool people, attractive people, but cool people. All people are attractive. To do all these things that I've listed here, I've taken off some of the things that we were filled out on. Now we've got like lots of people available to operate sound. But I really need help before the show, like making these kind of slides and stuff, and just putting stuff together. It's not that hard, but it takes a bit of time. And yeah, when I'm in production season, there's not a lot of time, and then I don't sleep, and it's not fun. Anyway, okay. Hey, cool, be cool, and join our mailing list. So this is where I used to say, oh, I made a dick joke, right? I was like, okay, we're only going to send you tasteful dick pics. And then I'd click the thing, and someone named Dick would pop up, like Richard Nixon or Richard III. And I was told that was juvenile and immature. Yeah. Gregory Peck showed up last month, and I had a promise to not do any more. Okay, did you get it? Thank you. Blue-footed booby. At least not a dick joke. All right, join the mailing list. No blue-footed boobies or Richard Nixons. Agenda tonight. We once again bring 2 interesting people to you. Well, I mean, they came on their own. We didn't really bring them anywhere. You know what I mean. First, Sophia University professor Edyta will... I need you to whisper your name in my ear again right before I introduce you for the main thing so I can get it right. I'm sorry. I can mimic well, but terrible memory. We'll introduce rotating detonation engines, a promising new technology for space propulsion. I really hope it's more impressive than the rotating detonations I had last week after eating way too much cream cheese. Well, I made bagels. Our second speaker tonight is augmented reality expert Stephen Black, who will also have to come up and whisper his name into my ear for different reasons, who is going to deploy his digital creations right here in this room. Stephen, where are you? You brought the bodysuit, right? Do you bring the bodysuit? Great, super. I'll get right into that. You can whisper your name in my ear. After each talk, there will be a Q&A. Please wait for the mic to ask your questions and keep them relatively brief, please. Right, so just a second. I'd like to introduce you to Dr. Dzieminska, who is an associate professor at Sophia University and works as the head of aerospace and combustion labs. I just wrote that badly. Where she works as the head of aerospace and combustion lab. And there, she also works. Sorry, I can't write apparently today. Should have got ChatGPT to do this. On the rotating detonation engine and detonation safety. Important to have safety with your detonations. I wasn't given a lot of personal info to work with, but luckily, Daria is her former student and provided me with the following. She was born, we'll see if it's accurate. She was born in northern Poland among the wild forests of, another word I don't know how to say, Dzieminska. Oh, yes, of course. Say it again. Dzieminska, yeah. Who studied in, it's not Warsaw, though, in Polish, is it? Warszawa. That's where she studied. I'm not going to repeat it again. And then did her doctorate at, this is really hard, Aoyama Gakuin. She passed the first stage of astronaut selection for the ESA. This is true. I didn't make that up. I think the second stage was making sure you hadn't eaten any horrible cheeses, but thanks to living in Japan, she had that white stuff they call cheese here. But it's all good, because she's here with us tonight and not on some moon of Saturn eating Parmigiano Reggiano. Also, this is neat. According to the Sophia University website, She belongs to the following societies: the Japan Society for Aeronautical and Space Studies, JASAS, the Japan Combustion Society, the International Combustion Society, and the Japan Explosive Society. Basically, she sounds like a blast. I have in my notes here, pause for crickets. So flap your flippers together for Edyta. And I gotta give you the other.
All right, can you hear me? That's okay. But can you hear me? I think I'm not connected to system. And I'm on? Yes. Mówię coś? Hello, can you hear me? But I'm not, am I? There you are. Yeah, okay. Can everyone hear me in the back? Okay, great. Yay. So thank you so much. Thank you so much for having me tonight. It's a pleasure. It's a very diverse crowd, and I will try my best not to bore you to death. So yeah, everything that Andrew said was true. And now I understand why I'm here. I have a weird hobby. So just to add up, I was studying my master's at Warsaw University of Technology, and I graduated from aircraft design, and then I did propulsion systems. And I really wanted to be jet pilot when I was kid. After watching Top Gun, I thought like, yes, this is the best job for me. But then I realized that army is not that much fun, so maybe how about we design aircraft? And I ended up at this very specific faculty in my country, which you learn how to design aircraft from zero. And then for my master course, I got engaged with Student Space Society. We did really cool stuff, like first Polish satellite ever, which was called PWSat. And then nowadays Poland is doing much better. We have first astronaut coming from Poland who will be in space anytime soon, actually. And what he said, he's bringing pierogi to space for the first time. So we are all very excited about this. Yeah, and I will try to keep my time, so I have 20 minutes. And I came to Japan to do my PhD about in 2010. And I came for 3 years. It's been very nice 15 years now. And I started working at Sophia right after my PhD. I had no idea what I was doing as a young professor. I was given a lab to run and teach some random classes, which I had no idea, but somehow all went good, and I'm really enjoying it. I love my job, and today I will try to share my experience from my work, which is detonation engines, which are really becoming the future of space. Whether it's going to be first, second, third stage of rocket, or maybe we will use them in a deep space in some future, this we don't know yet, because there are many challenges to overcome. And I will try to explain you what is detonation also, because it's not just kaboom, but actually it's a bit more complicated process. Okay, so this one is, okay, so in the word of combustion, we really want to know how fast we burn things. So when we talk of combustion, we actually try to answer a question, what is the combustion velocity? Not how fast things are moving, but how fast fuel is disappearing from the tanks or the engine. And if something is slow, meaning Mach less than Mach 1, then we call it a deflagration. It's your fires, it's a cooking stove, it's burning wood, it's a jet engine. All of that things are using deflagration. And when you see flame, this is what we call deflagration in this field. And the fast combustion, which is above Mach 1, it's called detonation. This is the slide actually I give to students in the or second year when we are studying a little bit of combustion. So this is exactly what they get to understand what happens from physical point of view. So for those of you who are more physicists, you can understand the pressure and volume changes. Long story short, oops, this way. Long story short, for example, paper will burn with about 2 centimeters per second, to give you some perspective. The fuel in the car will be burning with flame about 45 centimeters per second. But in my lab, we use fuel which is called hydrogen, which you probably know. And the combustion speed is about 2 kilometers per second. So in this type of situation, the shape of flame cannot be sustained anymore. So what we get is something which is called detonation wave, something going extremely fast. This is our pictures from Schlieren system to show you how detonation look like. So Schlieren is also really cool. You can check YouTube videos, there are many. Like if I move my hand, or even air conditioning, you know the air is blowing, but you cannot see it, right? So if you play with shadows, if you have just like mirror and some candle, you can do your shadowgraphy at home. And or sometimes when you are sitting at home and there's a nice day, but you have air conditioning inside, you see the shadows of air moving on the floor, right? This is called Schlieren system, basically. And this is what we use to see detonation moving. So this is from my lab, where we are working on detonation safety also. So we detonate in order for things not to detonate. And this is some other image just to show you. This is aircraft engine. This is where engine is not working, and this was made in air tunnel. And when engine is working, you can see these very beautiful lines going through the engine, creating the perfect shape. It means that the air is coming at exactly the right direction and velocity inside the engine. And this one is called spherical shock, like when balloon is exploding, and you can hear it and you can feel it also, right? And detonation wave is like a shock wave, but additionally with shock wave, if we really zoom really a lot, we will have also reaction zone. So temperature, pressure, density. I put it for all those nerds who like to see graphs. So where this detonation engine is coming from, first I will give you like general idea why it became cool, and then I will go into details and explain why do we think that it's actually better for space industry. So this is recently NASA, December 2023, NASA announced that they are fully going into creating rocket with rotating detonation engine. And recently JAXA also announced that officially that they are also building a rocket with rotating detonation engine. One of the leading professors in Japan is Kasahara sensei in Nagoya University. So they are doing really cool stuff, and they actually they operated engine in space. They turn it on, proving that okay, we can turn it on and operate it in orbit. It is a big thing because it's not as easy as it seems, and operating new engine in harsh environment for longer than short time is also quite complicated. So now this is another point that we try to do, we as society of combustion. This is how this type of engine may look like. I put a lot of things on slides so you guys, some of you can read. I will not be just reading them, I will be just telling a story. Are these slides available somewhere? I don't know. Are these slides available somewhere to people, or we're not supplying it. Not supplying, okay. So a lot of writing, don't worry. So now we have this detonation, and we want to put it in the engine because detonation is a lot of power. If it's burning this fast, it means this energy of combustion must go somewhere. So if we can control it, it means we can create really cool machinery which can create a lot of power. So scientists came with this idea already. Zeldovich in 1940, he came up with this initial idea. He was really cool scientist for our field. He created a lot of new theories, but he was not allowed to go out from Soviet Union that time. And later on in Michigan, 1957, University of Michigan, Nichols was also working on this similar idea. And in 1981, my supervisor created this patent, actually, together with Japanese. I mean, he first published a paper of spinning detonation together with Michigan team, showing that, you know, this is a cycle, and everything that is inside this diagram is a work, and you use this work to power something. So, for example, what you see in the white part. This is almost like a car. The car engine has cylinder and there is a piston moving inside. So you can imagine that the fuel goes in, burn, piston goes up, it goes down, then up. And there is this moment when it goes up and down and we kind of lose this momentum, right? So what happens in rocket engines and detonation engine, we can have this spike because it's constantly rotating in one space. There's no going back and forth, putting the mixture. The mixture is constantly going, kind of like a stove in the kitchen. As long as you supply gas, it keeps on burning, right? So that's what I was saying. So my former supervisor from Warsaw University of Technology, together with Professor Toshi Fujiwara, from Nagoya University and Mitsubishi Heavy Industry, they patented this engine first in Japan. Then the patent was also in the United States. And that time, really, in the whole world, it was Poland, Japan, United States, France, and Russia, which were doing any sort of work in this field. Now it's way more. Now we have our own conference on rotating detonation engines, especially for that, which is super exciting because we are not just small bunch of guys who are trying to have our own session in a big conference. Now it became a thing, and it became really in fashion, and so many students want to study rotating detonation engine. And I will have more pictures in a moment to show you how the actual thing looked like. Detonation engines can be divided into three main categories. We have rotating, pulse, and oblique. Let's forget about this oblique, not that interesting. I will show you how I will show you how pulse look like, and I will explain why it's not cool anymore. And then I will tell you why rotating detonation engine is the only and coolest engine that you can think of. And then rotating detonation engine is divided into more categories. It's annular and disc shape. I will show you those two. We have them in my lab. We work on those two. And recently they are so-called hollow, so it's just like a glass. There's nothing inside. Actually, rotating detonation engines are super cool because they have no turbine, no compressor, nothing. It's just you have piece of pipe, you put some holes, you put gas in, and go. It's just we need powerful fuel. Kerosene would be very difficult to detonate, for example, but there are many researchers working on it all over the world. So this is pulse detonation engine. Step one, we have empty engine, we put the fuel and oxidizer. So remember, we need fuel and oxidizer. So if I have a bottle of hydrogen, just hydrogen is the safest thing you can have. Without oxygen, nothing can happen. Yes. Yes. As long as it's not leaking, and I don't have to remind you that hydrogen doesn't have any smell or color, meaning we don't know if it's leaking, it's safe. Also, pure hydrogen flame, it's kind of very much not visible. So another hint, don't go anywhere close if you're not sure what's happening. Anyway, we add some fuel, we ignite, there's a detonation coming out from side, and the cycle goes again. Now, this cycle is so fast, the detonation is just split of a second, so this ignition part must happen like all the time. So if I show a video how it works like, in slow motion, it will look like this. So you can imagine it's super complicated because we have to do ignition all the time, over and over and over, right? But the first flight was done in 2008 on a specially modified plane. So they went a little bit far, they turned off the actual engine and they started PDE and they flew a little bit. But Professor Wolański went to state and said, guys, you're missing the point. You cannot do this like ignition all the time. You need something better, and I have something better, which is rotating detonation engine. You ignite once, and as long as you supply gas and it's keep on going, because detonation is like a Pac-Man, for those of you who are old enough. Pac-Man is just keep on eating the gas around the chamber. If we put it on the rocket, it's gonna be also super simple. We just have some engine here, we have fuel oxidizer. We don't really need cooling system. We can use regenerative cooling system. It means that we have liquid fuel. The liquid goes around the walls of the engine, goes inside and evaporates meanwhile, because engine is hot. I forgot to say detonation may be 2000 degrees, so we are kind of battling with cooling systems if we play it in lab, but in space we're a little bit more safe with temperatures. And then we have and then it's like it's going. It's called regenerative cooling because we are using fuel to cool down. But in Germany, in Berlin University of Technology, they started this big project last year with detonation engines being combined with turbines, and they want to create electricity. Primary idea is hydrogen. So we really believe that there will be time when hydrogen will be very cheap and available. So it will be better for energy. Nowadays, it's neither green nor cheap. So still battling, yeah. In Japan, there is a lot of grants in ammonia nowadays. So Japanese government really believes in ammonia. So there is this, in Japan it's ammonia, in States it's more hydrogen. So depending where you are, people are doing different research because you somehow need to finance your research. Hence we are starting ammonia RDE very soon. And let me talk a little bit about advantages of this crazy RDE over regular rocket engine. So first, it's efficient. It's more efficient than regular rocket engine. This we know from lab study. It's more compact, meaning that smaller engine can create higher thrust. It's very simple. As I said, there's no moving parts, no rotating parts, no pistons, no compressors, no turbine, nothing. It's just annular chamber through which I supply gas. It must be high pressure, but then it's just simply going. It has higher thrust to weight ratio, so it means that we can have basically more thrust with the same amount of fuel when we carry. Super important if you want to go to space, because every kilogram, every gram counts. And the last one is variety fuels can be used. A really big range, but it's very difficult to, there's a broken glass. But it's very difficult to detonate something like kerosene, for example. And people are working on it as well. And you know what? I may go back to this slide because it's about disk RDE and I didn't even tell you much. So in my university, we work on two engines. One is called annular chamber with water cooling. And we, in this kind of particular project, my lab is working on cooling. We just think of how to cool or to what temperature to cool it so the detonation is sustained. And it looks like this. Looks very complicated, but most what you see, it's actually just the stand. It's something just, this back plate is just, the engine is mounted to it. It's kind of heavy, but the combustion chamber, this round thing around aerospike, it's just maybe 10 centimeters and 1 centimeter in diameter. We calculate this specific diameter based on detonation properties of fuel that we use. And the detonation is rotating in this part. So this is just like really like glass, right? If my glass is the engine, the outlet would be the rim of the glass and it would be going like this. And then naturally, if you simulate even this type of outflow, you will see that air doesn't fall inside, right? It's kind of like goes out. So here we have so-called stagnation region, which as the name suggests, nothing moves. So why not put something inside if this air doesn't move? So we put aerospike nozzle, and then the air works like on the wing of the aircraft. It sticks to that surface and just add a little bit more thrust to our engine. So we are helping basically to speed up the rocket just a little bit, but in every situation a little bit sometimes means a lot. And this is the blue thing is the water cooling that we have, and we have some oxidizer and hydrogen. Here we work with hydrogen. Why we work with hydrogen is not because it's amazing fuel and that's gonna be fuel for rockets. It's not gonna be, because the density of hydrogen is not good enough. But hydrogen is with air, is with oxygen, is very easy to ignite, very easy to detonate, and very easy to control. And once you have detonation, it's gonna be always the same. Once you have flame, it's gonna be flame. Doesn't matter if you started with wood, matches, or I don't know, candle or whatever, right? Oh, it's the same. It's the same with detonation. Okay, I added some slides. So we have some temperature measurements, we have some load cell, we have high-speed cameras. I just wanted to show graphs. I didn't know how the space looked like. Now I realized you just see lines on the screen, which is not good. So we have very small mass. We have 135 gram per second of mixture, and we only operated for 2 seconds. The longest we operated was like 10 seconds, but the engine becomes kind of hot and we turn it off. How do we know actually that is rotating? And it's super interesting because all over the world we are trying to figure out which way will it rotate. Will it rotate just one wave or two or three? Are they going the same direction or are they going counterclockwise? We don't know. We really don't know why it's happening, and sometimes the mode is changing. And for example, what we see here, that in this particular experiment, one is going left, the other was going right, or up or down, how you want to call it. For example, if we had higher mass flow rate, we had just one wave, but it's not the default. So this is still unrevealed problem. And it doesn't mean that we get less power or more power. It's still something to be solved. But we can calculate always the thrust, and here are some calculations we are just doing. We are measuring the water temperature. And you are maybe wondering, how do we know whether it's just flame, hydrogen flame is super fast, or it's really detonation? So most of you, some of you may know sound speed, right? I speak with sound speed. In this room, my voice goes to you with about 1,000 kilometers per hour. But if we fill this room, if we fill this room with hydrogen oxygen, my voice will be going to you twice fast. So it means if I want to create detonation, it must travel really fast, like otherwise we cannot create detonation. So by this theoretical calculation, we know that if we see in pressure sensor that something moves really fast, okay, detonation. Then let me skip that. We measure some thrust, specific thrust. We do a bunch of calculation, and that's how the research looks like. And then we came up, not we, but generally there's another idea called disk RDE, which basically looks like a disk. It's a little bit more complicated to explain when you don't see the picture. It's something that looks like this, very, very simple. Detonation is rotating inside that disk. So if my hand is a disk, detonation would go like this, and it will be leaning towards the outer layer. It's just going around, and the fumes are going out here. This type of engine was used on the first rocket. I don't have a video here, but first rocket was launched in 2023 by my colleague in Poland, in Warsaw Institute of Aviation. They shoot a rocket with RDE from ground, proving for the first time in the world that you can do it, which is very important step. So now we have two very important research done. One by Polish team, stating that we can start a rocket and put it on really some height with rotating detonation engine starting from zero. And the other important research by Japanese team saying if we bring the same rocket engine up to the orbit, we can operate it. So it means now we just have to put it together. It's not that simple, but if we just put it together, we can have really cool propulsion system. I'm really running out of time. This is our engine at Sophia. Actually, we use wind tunnel in some company right now because it's kind of noisy and university is not very happy of us. So we have some pressure sensors and so on. And I keep on going back. So this is very short experiment. It lasted only 0.4 or 0.5 seconds, but you will hear the engine. People who are close to projector, be aware. This is it. The detonation the detonation part was like the whistling part. You will hear this one. So at the beginning you just see high-speed gas because first we dump the gas and then we ignite, and when you hear this like whistling sort of a thing, that's detonation. Normally it's very loud. We wear headphones, noise cancelling headphones. So initially scientists, researchers were thinking that's gonna be great for airplanes, like we will put it on airplanes and everywhere. You don't want to be on that airplane, trust me. You don't want to fly that airplane. And that's how we see. I just want to show you how many times detonation is rotating. So this is the test of pressure taken by pressure sensor. By the way, for those of you who are interested, pressure sensors do not measure pressure. Pressure sensors measure change in electrical current, and based on that we know the sensitivity and we can calculate what is the pressure, actual pressure. So here we are. This is 0.001 seconds and this is 0.002 seconds. So every microsecond we have one rotation with this fuel. It may change based on the fuel and mass flow rate. Summary. My time is up. So in summary, rotating detonation engines are believed to play an important role in future of space propulsion systems because we proved all over the world. And the fact that the biggest national agencies like JAXA and NASA started investing a big money into moving this type of rocket means a lot. And this one, just to summary my presentation, I was introducing hydrogen-oxygen disk rotating detonation engine to you, and the detonation process has been successfully observed in all runs, and also throughout the runs the mixture strength and equivalence ratio were consistent, meaning that we can have consistent thrust to put something like that and operate the rocket. That's all, and are there any questions that I can take? I'm sorry if it was too technical. I really try my best to.
It's two. So yeah.
It can be any question.
We can take questions. So I saw Melvin's hand first, and we'll just do that so we can get the microphone out of this corner. And where's the other mic? Because I'll pass that one around too. Oh, why don't you just grab that one? Sure. And then I'll pass this one. Who else had a question? Just so I can. Yeah. Okay.
Okay. So like, oops, sorry, a bit hot. My question was like, you noted in one of the slides there, like there can be multiple flames in like possibly going in counter direction or like in the same direction. So like, how does the number of flames and like the direction potentially affect like the output, like the power output of the engine? Mm-hmm. And I'm not a rocket scientist in any sense, but like I'm still struggling to understand how like we're basically using the speed of explosions as like to almost like self-govern this process. How would you adjust the power output, like with like, like basically with an accelerator? Is it just the fuel flow involved there, or is it something else that I'm not quite getting here?
So we don't know. We don't we don't know why it happens, but if it comes to power, it's the general thrust of the engine doesn't change whether we have one wave or two waves or three waves. The pressure from these waves will change. So if it's one, it's going to be higher. If it's more, it's going to be less for each wave. So we don't say flame in this case, we say detonation wave. And the thrust really mostly depends on mass flow rate. So how much fuel we're pumping into the engine, basically. Does it answer your question, or did I miss something?
Well,
I missed something.
Yeah, no. It answers my question. It's just like the science is not completely clear yet. Is what I'm getting here.
Yes, we are really working hard. There are many theories, and each conference like brings some new results. But I cannot tell you exactly like this is the right theory. Yeah, for sure, mass flow rate is very important. So if the mass flow rate, meaning if we are not pumping that much, let's say if we have only 80 grams per second, we see the process is kind of unstable. So it's 1 and then changes into 2 and going back and forth. But if we have very fast flow, it kind of stabilizes at either 1 or 2 waves, and then it's ongoing. Also, there's another problem which recently got revealed. So if we operate the engine in vacuum for longer than few seconds, it changes the output. And yeah, so there are many challenges still ahead of us. And there was a question here.
All right. Thank you very much. That is a really amazing presentation. Very informative.
Thank you.
And you mentioned a lot about future of space propulsions. I have two-part question here. The first part will be what is the current technology readiness level of this, and what is the second part will be what kind of applications that you envision RDE will play in space propulsion. It could be movement in the orbit, or it could be SSTO, maybe single stage to orbit, maybe. Could you please explain to us what is envisioned?
I think I'm not sure if the first stage would be the correct one. I would imagine it's going to be maybe second stage, or bringing it into orbit and then starting it in orbit. Or another way, here maybe I can say, but generally Japanese university, my university does not allow us to say it can be dual technology. But let's say it can. There is a lot of military interest in many countries in this technology because it can speed up quickly and have suborbital travel, let's say, for some small rockets.
Let's keep that between us. Can I have a very quick overview about the technology readiness level, if you're okay with sharing that?
I didn't hear the
TRL.
technology. I didn't hear the
Technology readiness level.
readiness level. I'm not sure how
if it's okay with you, if you're
so
comfortable with sharing.
I will tell you like this. In December 2023, actually January 2024, JAXA announced that in 10 years they will have fully operating rocket with RDE. Yes, so that's all I can say right now.
We believe you. I believe you.
Yeah.
So 6, basically.
I don't know what the level is.
So my question is, when you're starting it, right, and you fill it up with the fuel air mixture, right? How does it actually start rotating as opposed to detonating as a pulse?
Very interesting question. So it's very interesting natural process. And so Professor Wolański was first working on spinning detonation, and what he noticed is that if you have engine which is like a glass, right, and let's say it's operating this way, so if you have a hole for fuel around the rand, even just imagine really glass, and then we put holes here, the fuel goes, we ignite from one side, doesn't matter where. The detonation starts spinning. Detonation starts spinning like this. It's natural, like a Pac-Man, really. And what happens is that if this is the inside of this glass and this is outside, this part is a little bit weak. So they thought, okay, if it's weak, maybe we don't need it, and hence they put annular chamber, and they have a ring, and then the wave is really going around. We start with in initiator because it's easy for the lab. Initiator is just a tube. We have fuel oxidizer here. We have calculated distance, so we know detonation will come inside the chamber like this, and then it hits the wall, right? So it goes both directions. And at the beginning, we have 2 small waves, and they start going around, and one of them is always stronger. Whether they transform to 2 waves or 3 waves again, depending a little bit on mass flow rate, a little bit on the shape of the engine also. Yeah.
Cool. Thanks. And this wasn't a prepared question. Just
I know
didn't know.
there's also a question
Who's the
there
next
and
person?
there.
Oh. Okay, I see.
There was one question also from there. Yeah. No juice.
Testing. Okay. Ooh. All right. So you spoke about how different governments have funding interests in different sort of fuel sources.
Yeah.
Is there one that is perhaps, some advantages to certain types, or is there sort of perhaps one that is emerging as a clear leader? Just interested about that.
I think it's betting of governments based on some meetings with specialists that they just bet that this is gonna be the future of fuel. Japan has potential for ammonia, and not many people were using ammonia, so maybe they thought, actually I don't know. I don't know what they thought, but they thought ammonia because it's NH4, right? So we have N and we have 3 hydrogen atoms. So cool, we have combustion reaction, a huge amount of hydrogen coming. So also as a byproduct, we have hydrogen. The problem with ammonia is it's very, very poisonous. So if you burn ammonia, it's really dangerous. So you really have to make sure that the exhaust from engine is properly catalyzed. So first maybe you put it in a tank, and then through high temperature, maybe like 300 degrees catalyst, you can release to air. Otherwise it's really poisonous for humans. Hydrogen, on the other hand, the product of combustion of so-called perfect reaction, is water. But you have to remember, this is what they told you. It's school chemistry 101. H2 plus O2 is equal to H2O. However, in the real life, there are about 19-20 reactions, because everything splits, right? There are 2 atoms of hydrogen connected in bond. This chemical energy, because of heat, is broken and transforms into heat and something else. And then this atom of hydrogen will interact with something else, so we will have OH, and this OH will interact with O, and we will have something else. So all this elementary reaction, we will have 19. So for example, when we do numerical analysis also in my lab, and we do numerical analysis of safety of detonation, you want to have really all possible reactions to really know how much energy will be released. Now, hydrogen, oxygen, super easy. Or maybe even air, because you just add N2, still like 21 reactions. But if we have to do, let's say, acetylene, hundreds and hundreds of reactions. Supercomputers cannot handle it right now. So we have to do reduced models. So I don't know why did I went so far with explanation. I'm sorry. And there was question?
Well, thank you for the presentations. It's very simple questions probably. I have no idea about any propulsion engines, but I'm wondering what's the difference between the propulsion engines that we have today, that we are using in our rockets today, with RDE, and what's the advantage of RDE compared to these other propulsion engines?
Oh, the wrong direction. I need one slide. Can we turn it on? Okay, this comes from theory, and in this type of science, any gain, even if it's 1%, it's a lot. So as I was showing this graph with work, let's say can I find it? Yeah, so when we have a car, the amount of work that car can do, it's not that much, and and it's kind of reasonable, because if you think about this, I will fly my car to the moon. No, it's not gonna happen. So hence we've built rocket engines, and then rocket engine goes like this. So everything here means it's powerful. Now, when we plot what detonation engine can do, we will have higher spike basically. We will be higher here. So this really small percentage creates better engine because it will be more efficient and more power. That's, I think this is the simplest answer I can say. So we know it because of theory. Yeah. And why it's better? Because it's simple. We skip all this, you know, jet engine is the most sophisticated equipment that we have in the whole technology world that you can imagine. It's really very complicated. And this engine is really like a glass. Like we can do engine right here.
Thanks for the talk. I have 3 questions. You can choose to stop me whenever you want. The first one is, I just want to continue the earlier question about the rotation. I was just wondering, do you like somehow induce directionality to that rotation when you first introduce the fuel, or yeah, I don't know how to complete that question.
Can I answer one by one? So this question, people tried. And there's one Chinese team that claims they can do it, but we've seen their presentation and we are not convinced. Let's put it this way. So not yet.
Okay. Second question is like, you said this is basically self-sustaining detonations, but how do you in general envision to induce the first detonation?
Okay, so in the lab we use initiator, and this way. I think it's in some picture. Actually it's here. Hard to see, but there's a metal pipe. It's all stainless steel, by the way, because of temperatures. Here's a pipe. Here we will have fuel and oxidizer connected, and this is a spark plug, like from a car, 180 N sort of a thing. So we just put electricity, spark, and these ignites, and in this very small pipe, it's 10 centimeters long and 5 millimeter in diameter. We create very small detonation wave, and that detonation wave goes inside and ignites the first one, and it's done. And there's no like backfire that nothing goes out. So in lab you can do it because it's easy, simple solution. Now in the engine, obviously you don't want to bring it because it's too complicated. So other labs are testing explosives. So you can order it from actual company. You can ask them for do like small button sort of a thing, and you will have it somewhere in your engine. And hot wire enough. Actually, even if you have hot wire, okay, I want to tell you a funny story. So my colleague, I think last year I was visiting their lab and I stayed for a month. We were working on one engine, and I really love working with them because they are doing things quickly and they test a lot of new stuff. And they got this really good idea, you know, the firecrackers. Firecrackers are great initiator because they burn with, there's a time until they burn out, right? So you can just put one of them inside the engine, quickly run out and start the fuel. This is what happened, and it worked. So, so firecracker temperature was enough to start the engine. Though I think for rocket is not the best idea. So I would stay with tiny explosive which you put in and just heat up and they explode and start.
Okay, but that kind of poses a limit to how many times you can operate remotely, right?
Yes, that's true. Yes.
Because like people are thinking of refueling rockets in space, right? So
yes.
That also adds another complication.
So there's third solution, which is.
Sorry, the only time we're at time.
Oh, sorry.
She's been waiting to ask a question. So you've got the mic, right? Yeah. Go ahead.
Presentation and making us feeling more hopeful about space travel. And so the just a simple question is, what about the lifespan of the engines compared with the conventional engines? About the durability and how reusable it is. And
very good question. Hard to say. Because now we just operated, the longest was like maybe 20 seconds or 1 minute inside the lab. So we really don't know. This still away. But you know, the biggest problem is the temperature, because temperature will be very high, can melt the engine, but in space, it should not be the problem. So for one mission, I don't know what's gonna happen. I just wanna address that one. Third way of igniting is a spark plug from aircraft, like jet engine. So this small thing, maybe 100 millijoules, Aircraft engine spark plug, it's like 5 times stronger. But it's spark plug is difficult sometimes to ignite because right, there are two things and the spark is going from one side to another, and you have to have atoms around, atoms of fuel. If you don't have them, you can spark as much as you want and it's not gonna ignite. So that's the problem with spark plug. It's not always efficient, hence we use this detonator first.
Okay, thank
I
you
think
so much.
I'm
we're
so
at time.
sorry,
No,
yeah.
no, it's not your fault at all. No, it was wonderful. Wonderful talk. Thank you so much. Can we put our hands together?
Thank you.
And I'm just going to switch back over here. Oh, so we're going to take a break. This is a good time to buy drinks. We'll be back
Sorry.
right at 9:15 because we've got to plow through. We've got a lot of material to get through in our second talk, and we've got a little mini talk at the end. So go get drinks and stuff. And we should be in. Oh yeah, no, that's right. That's the right slide. You can bring the sound up on that. Yeah. On the music. Is it not sending? Wait.
Oh, little boy, little girl, little person, little jumpsuit wearing sequins. Well, it's time to stop your midnight driving and put your dancing shoes away. A little woman, little man, little grown up, little platform wearing disco fan. It's time to stop your late night shaking. It's the end of a long dancing day. This is a disco. This is a disco lullaby. Lay down your funky head. It's time to go to sleep now. Go get tucked into bed. Your daddy and your mommy will boogie shake their bunnies at the disco scene. But first they'll tuck you into bed and you'll disco in your dreams. Disco dreams. Oh, little boy, little girl, little person, little jumpsuit wearing sequins. Well, it's time to stop your midnight driving and put your dancing shoes away. A little woman, little man, little grown up, little platform wearing disco fan. It's time to stop your late night shaking. It's the end of a long dancing day. This is a disco. This is a disco lullaby. Lay down your funky head. It's time to go to sleep now. Go get tucked into bed. Your daddy and your mommy will boogie shake their bunnies at the disco scene. But first they'll tuck you into bed and you'll disco in your dreams. Disco dreams. Good night, you'll be alright in your disco dreams.
Up. There we go. Hey, everybody, this is your 5-minute notice. We're back on in 5 minutes. So grab those drinks. Use the toilet, which is the opposite of grabbing a drink. But you don't necessarily have to grab anything in there. I'm going to shut up now. 5 minutes. And we're back. Okay, so this is the moment in the show I'm supposed to remind you to buy beakers, but we don't have any. So blip. Our friends at Tokyo, I can't talk, I'm melting. Tokyo Humanities Cafe, they also do a show here. Wait, is Alex here tonight? No. Okay, well, I can't tell you when their next event is because I don't know because they didn't tell me. Anyone from Tokyo Humanities here? I see people at the back looking like they might be, but anyway. Okay, never mind. So anyway, they're really great. They're here. Check the QR code down at the bottom. Check them out. They're awesome. And they just, Alex... Oh, yeah, Alex just did an interview in the Japan Times. So if you look up Tokyo Humanities Cafe, Japan Times, you'll see something there. Space Cafe is a thing that happens. Are you kidding me? For fuck's sake. Hold on. I went through these this morning. What the hell? What number is this? 17. Yeah. That's not. Hold on. I got it. Hold on. All right, I'm fixing this right now. There. I'm sorry. I must have put it in and forgotten to save it or something. Thank you. Anyway, yeah, they're doing a thing, and it's soon. We're the 18th now, so is that Monday? Tuesday. Oh, yeah, you're doing it on Tuesday. Yeah. So they've got a speaker who's talking about Niels Bohr, and I'm not going to make the obvious joke that how many Niels do you need? Anyway, boop. But go check them out. They're fun. Yeah? Anything else you want me to add? No, that's good? Okay. YTG. I'm going to rip through this because I left my notes over there. Yokohama Theater Group, YTG, is the company in Japan that runs Nerd Nite Tokyo, and we are a non-profit theater company, and we do this, and we make theater shows, and we do like a lot of non-commercial stuff. That's why we're a non-profit, but that means that we take a lot of big risks. So yeah, theater, like when you do contemporary theater, it's like high risk, low reward. So if you want to support that, that's a QR code. But you're supporting it just by being here, so thank you so much. And I'm going to move along because we are pressed for time tonight. And I'm going to introduce Stephen Black, which I do need my phone for. Because I wrote a whole thing. There's a whole thing here. Yeah. Speaker number 2, Stephen Black. Stephen Black, that is how you pronounce your name, right? Okay, all right. I should have checked that first. Is recognized as a pioneer in location-based augmented reality and has given presentations at Hong Kong PolyU, TechCrunch Shenzhen, Columbia University, the View Conference, and twice at MIT. From developing black and white film in the dark rooms of Rochester Institute of Technology to making history in the metaverse, Stephen Black has a long list of accomplishments in the visual arts. He worked as a producer for Cartoon Network in Hong Kong and for Fuji TV in New York. That's right? I didn't just splice two things together there. Great. He collaborated with Michael Lee on an installation for the Singapore Biennale. While living in Tokyo, he and, how do I pronounce that? Barai ran an artist space in a 6 tatami room. He made music videos for Sadato/Popbiz and Kumiko Akiyoshi. He has documented many Buto performers, including Min Tanaka, Atsushi Takenouchi, and Kazuo Ono, only 2 of whom are still alive. Draw your own conclusions. With Sayuri Okayama, he co-created Bubiko Food Tour, AR's first superstar. His bio says this, but I actually don't know what that last sentence means. Perhaps you'll explain it. Yeah, he is the author of several books, including the best-selling I Ate Tiong Baru. Is that kind of how I pronounce that. His presentation tonight is part of a national tour of Japan. You may have seen his tour guide outside. He's the one holding the little yellow flag with everybody. Sorry, it's a Japan tour guide joke. Anyway, give it up for Stephen Black, please. Yay!
Okay, 1 2 1 2. Can everyone hear me? Can? Yeah. Yes. One two 1 2. Check
There you
1
go.
2. Check 1 2 1 2.
And you got the clicker?
Clicker. Okay. Okay. Okay, history, one-dimensional paper. With electricity, we had radio. Eventually, we had television. Then we had computers. Augmented reality is spatial computing. And that's what I've been focused on since 2015. I'm Steve Black, and I'm very happy to be here. Thank you to the organizers, and thank you all for coming. I don't know what I'm going to talk about. Maith is the company, the organization that I now have. It officially became a company, but before it was just an idea. Maith started in the Irish Cultural Museum of New Orleans. I did an exhibition in AR about soda bread, and that happened by chance. But at that exhibition, you could see soda bread, pieces of soda bread in space, recipes about soda bread, and you could see videos. Maith is actually an Irish word, a Gaelic word, and it means clear or very. Depending on who you talk to, it's pronounced Maith, Maith. There's a few other pronunciations that it's always different when I speak to a Gaelic speaker. Maith was the result of a process of a series of events that actually started in 2002. I had worked for a television company in Singapore, in Tokyo, and I had some friends that I met in Hong Kong that were in Singapore. They were Japanese, and they were TV producers, but they started a $3.2 million startup in Singapore. And the man who set it up was my friend, and he was a genius, and I don't say that lightly. Eventually I moved to Singapore to work for him as a creative director. We were doing 2 tracks. One was something exactly like YouTube, but 3 years before YouTube. And the other one was a creative development kit, a game making kit for 3D game making for kids. And it was going very well. It was going very well. I was out of my league because my background was in photography, video, writing, and things like that. So finally, October 24th, 2004, we premiered this software at the Singapore Science Center. And the morning of the premiere, he died of a heart attack. So, personal loss, professional loss, everything was, that beautiful ship ended up on the rocks. He left no chain of command. So very difficult time in Singapore, not knowing what to do. But I thought there will be a happy ending. I learned so much, and his spirit was so strong that I said, somehow this will continue. I went from knowing nothing about polygons and C++ and programming to, I'm not a programmer, but I learned so much that I thought this can't go to waste. But at that time, and at my age, it didn't make sense to go into working for video game companies or computer game companies. And anybody doing anything with education probably had a small budget and they didn't need an extra hire. So I wrote books, I did a bunch of art stuff. And then in 2015, the Oculus came out. If you know the Oculus, it was a headset, and I thought, wow, this is a level playing field. This is a brand new thing. I have experience with 3D. It's with the flat screen, but now's the time to reemerge. And after about 6 months, I realized that VR was not for me. You need a team, you need a big budget, you need a long runway, as they say. And I had a lot of ideas, but my heart wasn't into it. But this little thing called AR really got me excited, because with VR, you're locked into a headset. Anybody that does anything with VR needs a headset. And there's all kinds of headsets, all kinds of complications. But AR, you just need a phone. And so I started to learn everything that I could. And suddenly, I'm trying to keep this very brief, but there's a lot of other personal adventures involved in this. But eventually, I was invited to speak in Bangkok, Sophia University, about presenting business data in AR or VR. And then I went to Hong Kong, and I did some workshops. And suddenly, I got a one-line email from MIT. And I thought it was a joke. But what had happened was, when I spoke at Bangkok, I asked for permission to use a video from MIT, and no reply. But they evidently had been following me or something. Anyway, I gave a talk at MIT, and I've never been more nervous or more out of my league. I think, actually, I'm probably more out of my league here than I was there, but you guys are, super technical, and I really admire what you're doing, and I'm honored to be here in front of you, but really, I don't know anything technically. So things kept moving, and eventually, I ended up doing the thing in the Irish Cultural Museum in New Orleans, and it was called Maith. That technically is the first permanent AR gallery in the world, and it's in a nice place in New Orleans. So that's what Maith is. Okay, that's me at MIT, and that's Bubiko, and this is Bubiko. And Bubiko was a lot of things, but it was also the realization that everybody in AR at that time was either with a big, huge company like Google or Apple or the equivalent, or they were with a big university. And I was committed to being in it, and I thought, well, if I create a character, and I was with a woman named Sayuri Okayama, and we created this character, and we said, eventually, Bubiko is going to be able to walk on tables and fly in the air, and it'll be augmented reality, and it'll be really exciting. And that was in 2015-ish, and now that's finally happened. But when I spoke at MIT, my talk was called Bubiko and the Unicorn, and if you know what a unicorn is, that's $1 billion company. We didn't say she was going to be $1 billion company, but that industry could be $1 billion company, and AR is certainly becoming financially important, or at least making a lot of money for some people. But when I was at MIT, I used what I had been using in Southeast Asia, which was a paper doll of Bubiko on a wire. And I would say, oh, hi, my name is Bubiko, do. And I would walk around and do that on the tables, and I guess it was a success because they invited me back. But yeah, we were also trying to make a book. When we were in Shenzhen, and we wanted to make a physical book. Shenzhen, I don't know if you know Shenzhen, China, but it's very interesting because it literally shot up in like 20 or 30 years. It's just boomed. But because of its financial success, it has restaurants and people from every province in China. So the idea was that we would make a book about Chinese food, but reflected in the restaurants in Shenzhen. And that's a project that's dormant. So, okay. Sorry, I'm very dry. So, I'm self-taught, and I kept thinking, well, Google's doing something, Apple's doing something, Microsoft, blah, blah, blah. Everybody's doing something. Are they going to be able to talk to each other? Is this going to be like the internet, or is it going to be a bunch of silos, as they say? And I was really, really puzzled by that because I just didn't know. And so one day I found a podcast and I was listening to the founders of the OARC, and I was shocked because these super technical people were talking about things that I couldn't understand. They were saying, yes, there's this, and I thought, geez, that's exactly what I was thinking of. So in the comment section, I wrote, thank you, you've saved my sanity. I didn't know what was going on with this. But the OARC is trying to make an open and ethical spatial web. As I did in the beginning, the spatial web, we want it to be open and ethical. So they invited me to speak, and again, I'm out of my league. And in fact, I didn't speak because they had an open floor, and I was supposed to speak at like 4:15, and at 3:45 or something, they had an open floor. And I was just listening to all these people from all over the world talking about technical standards, and I said to the organizers, I said, forget about my thing. This is such a special thing that all these people can just sit together and brainstorm. So even though I was listed, I didn't speak. But the question was, what do they call me? And at one point they said, well, we want to call you an evangelist. I said, the problem with the word evangelist, because I was doing a lot of projects and I knew all the members. There's actually 3 members doing really cool stuff with spatial computing in cities and stuff like that. And I was doing my own project. So they said, well, we want to call you an evangelist. And I said, you're all volunteers and nobody's paying me. The problem with the evangelist is that people think that I'm getting paid, and that's not the case. So I'm the spatial cinema artist of the OARC, which is funny because the technical limitations are such that you really can't do anything close to spatial cinema. I'm trying, but it's 5 years down the road, maybe. So that's the OARC. Okay, now, the OARC is on very good terms with the Metaverse Standards Forum. Now you're shaking your head. Do you know? Has anybody ever heard of the Metaverse Standards Forum? Okay, so the Metaverse Standards Forum is trying to create standards for the metaverse. I don't like to talk about the metaverse, but there's one thing that I should say. So in terms of the metaverse, everybody thinks it's VR to VR, but they have a working group that's focused on real and virtual world integration, what some headsets call pass-through. It's a whole thing unto itself. So the OARC, very closely linked with them, and the OARC is actually creating projects based on their suggested standards. So what does that mean? The first, Helsinki, Finland, or Bari, Italy, I don't know which was first, but they created, in Bari, 100 square kilometers where they scanned the whole city. If some of you were here earlier and saw me do the demonstrations, in this building, and I hope you can all see this before you leave, I scanned this section here. I came in about 4 or 5 o'clock and I scanned that, and then I sat at my computer and put in some simple pictures and a cat and a gnome. But in Bari, Italy, they scanned 100 square kilometers. And the first public project to be in there was Bubiko. And technically, that Bubiko is the first project in the metaverse. And it's theoretical, but it is the metaverse standards. They're probably not going to change. So if anybody ever asks you what's the first project in the metaverse, it's Bubiko. Okay, and there's a video about it, 10 pieces of information about it. Okay, this is from, so what did I make there? If you understand what's going on with spatial cinema, you can have augmented reality content, and then it's linked to a physical location. So if you go to Bari, Italy, and go to about 10 different spots, and you have the app, because that's app-based, you can see Bubiko flying around. That's all she does. I mean, a little bit of background. I was invited to speak at the View conference, which is in Torino, Italy, and this was at the peak of COVID. And I thought, oh man, what's going to happen? One of the things that they said was, okay, you can come to Italy, but you have to come 2 weeks early because you have to be in quarantine. And I thought, oh man, okay, well, the View Conference, again, I'm a fish out of water. The View Conferences are like people that work on Star Wars and, you know, big, huge budget things. You know, I can't believe that I find myself in these situations. But anyway, so I first I go to JFK, and JFK Airport is empty. And I say empty, there's like one other person walking around. And he sees me, and we're by the Italian Airlines or whatever, you know, I'm going to Rome and then to them. And he said, first thing he said to me was, hey man, I've got a filter for you. He says, normally they're charging $50, but I've got an extra one here. And I was like, wow, thank you. So that was on a Friday night. I didn't leave until Saturday. They called Rome, they did all the stuff. The people at View wrote paperwork. Anyway, so I get to Rome, and then I get to Torino, and I'm thinking, okay, I've got 2 weeks in a hotel room. I get to Torino, no one cares. They just don't care. So I go to the venue, and the venue's like, well, you know, the last wave of COVID was so hard that we actually became a hospital. The venue in Torino is fantastic. It's an old railway station that they made into like a civic center, and it's got a stage and all this stuff. It's beautiful. They said, you know, the last wave, we had people from all over Europe and even Cuba that came here. Okay, well, and they said, we think we're going to have to go online. So I'm thinking, what do I do? What do I do? I'm not going to hang around here, and I don't have to be in quarantine. I went to Bari, Italy, where that company, Augmented.city, was based, the city that scanned the 100 square kilometers. And within 2 weeks, we just put the pedal to the metal and made this little movie about Bubiko flying around. I made it into a silent film, and I've never publicly premiered it. I should do that. But anyway, there's a short film, and it corresponds to a physical location. Now, this is an important scene to me because when you're positioning something in space, especially in the beginning, you would have something called drift, where I could sit down and say, okay, I want it to be, you know, right here. And then you would get the phone out, and it would go. It's called drift. It's a big problem. Now it's much, much less of a problem. Now it's, I'd say 99% rock solid. But this was interesting because Bubiko, in part of the movie, is flying inside of a cafe, and then she circles the table. Now, at the time, we were all proud that the accuracy was within 10 centimeters. So in the movie, she comes down and circles the table and then flies off. Now, I won't make this into a big deal, but one of the issues was the table, because if they're cleaning and they move the table, you know, then she could end up on nothing, right? She could end up in your lap or someplace else. So I picked one particular table, and the tiles had a pattern, and as long as the legs of the table were on that pattern, it was foolproof. So that's a little behind the scenes of Bubiko, and that's in Bari, Italy. Some people say, what's the difference between scanning with these various AR systems and GPS? GPS doesn't work inside. So that's another big issue. Does anybody have any questions? Am I moving too fast, too slow, too raspy? Okay. So Maith, this is back to the Irish Cultural Museum of New Orleans. It was really interesting for me to start to work with 3D fonts in space, because that's a new thing. I mean, but this is, I think, information about Soda Bread, and that's the logo. Oh, Maith AR. Now we just say Maith. I just say Maith. Okay, another view of the inside of that. You can see the Soda Bread. A friend of mine in Natchez, Mississippi, is a professional chef, and she is also a historian, so she helped me with a lot of that stuff. The exhibition was actually called Soda Bread in Time and Space. Okay, I've done all kinds of stuff, blah, blah, blah. This is from another presentation. I just recycled it. The Notodden Blues Festival is in Norway, and what happened there was I because of my background in photography and this and that, I was doing some work for the Clarksdale, Mississippi Board of Tourism. And in doing that, I discovered that Clarksdale, Mississippi has a sister city in Notodden, Norway, where they have a blues festival. Now, the head of the OARC, the Open Augmented Reality Cloud, is Norwegian. So blah, 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 blah. Suddenly, we're going to the Notodden Blues Festival and showed some of the Clarksdale photos with AR there. You know, we invited ourselves to the party. They didn't know who we were, what we were going to do. As soon as they heard the word exhibition, that was the worst word I could have used, because they said, you know, it's in 2 weeks, we don't have space. And I said, you know, when you see AR, you'll understand. So we went and they loved it. And in fact, we were invited to another festival. The only problem was, of course, that they didn't want to pay. But anyway, Bagel Fest. I have another project. I should have prepared some video, but I have bagels that fly in the air as well. So blah, blah, blah. Okay, just different projects. There's Bubiko. This is at the Bitcoin Center of New York. That's Toronto, New York. This is in Ann Arbor, Michigan. I'm back in Toledo because, you know, of COVID. COVID brought me there, and my parents, and this and that. So that's where I'm based now. Okay, there we are. So this was this was the Macy's Thanksgiving Day Parade, and I thought, okay, we're going to put Bubiko in there with all the other characters. So you know, all this is self-funded, so it's really a big deal that I try and get some sort of tangible result. So I flew in to New York the afternoon before. I scanned. So just to review, when you use location-based AR, you have to create a digital map. So I created a digital map of different parts of New York where I thought the parade would be. Did some testing, everything worked fine. And then the next morning, I go at 5 o'clock, and of course the police have blocked off different parts. I was prepared for that, but you know, suddenly I'm very far away. And okay, I'm all excited. If you ever do anything like that, remember to buy some diapers. I didn't need them, but you can't find a bathroom in New York anyway. But when you've got 50, 60,000 people there, you know, you want to be prepared for all situations. So I'm in position, and I think, oh, this is a great position. And as soon as the parade starts, no signal. I can't get anything to happen. I'm talking, you know, to the people in Italy, trying to get, because at that point I needed an app and I needed their support. And I'm saying, you know, what's going on? I can't get anything. They couldn't find anything. We realized that it was because everybody was using the internet, using the, you know, bandwidth. So I'm trying everything. The last 3 floats in the parade are Sonic the Hedgehog. The very last one is Santa Claus, and the one in between is the Pillsbury Doughboy. And I'm checking everything, and suddenly the bagels worked. Bubiko couldn't work, but the bagels worked. So when you see the video of this, it looks like it was planned, but it was just dumb luck that the bagels worked with the Pillsbury Doughboy. Okay, so
Stephen, just a heads up. You're out of time. If you want to do your demo, you've got like 10 minutes.
Anybody that wants to see the demo, I'll wrap up. It's really, I mean, I'm sorry I talk so long, but the really cool thing is if you can actually see it in action. So I'll wrap up. Expo, this is I think the last slide anyway, but in Expo 25, I'm planning 3 kind of surprises with the Italian pavilion, the Nordic pavilion, the Bangladesh pavilion, and maybe the Irish pavilion. So I'll leave it at that. Okay, in Hamamatsucho, right after Golden Week, I'm doing a special exhibition. Finally, I've got a great space, and I'm going to make it a showcase of all kinds of AR ideas. So if it's free, and I'd love to see you down there. Thank you for your time. I'm sorry I went over.
No, not at all. I just want to make sure you.
Oh yeah, but the demo is really fun. I mean, when you can see it in your hand, you really experience what AR is all about. So
let's do that in lieu of.
Okay.
People can talk to you after
Yep.
they have questions.
Yep.
But let's yeah. So what do you need for the demo?
Oh no, that's just, I've done it to maybe 10%. I just drag you over there and show you on my phone. It's nothing. I'm sorry. I'm not doing it live in front of the group. I'm just doing it individuals.
Okay, so then we do have time for questions.
Oh, okay. I think that is absolutely the last one. Let me just,
Make sure then.
Oh, so I say 50 million people will learn about Maith in 2025. Thank you for being part of them. And that's my email. I've got a newsletter. It's maith.world. I actually have another one about Japan called Japan No Orbit, but it's not on there. Okay, that's it. So there we go. Thank you, everybody. Thank you.
All right, so I'm not holding a microphone. I need to grab questions. This one is on. Two is on. Hello. So, yes, right there. Okay.
Nope.
Easy.
Please don't be technical.
Okay, thank you for your presentation. Where do you see the practical usage of AR in the future?
Great. I just did something in Kyoto for an educational conference. So education, tourism, art. My background, one of the reasons I'm doing photography is because it's a really great showcase for photography and 2D art. For painters, they might not feel comfortable with a digital reproduction, but digital artists doing 2D. So immediately art, tourism, education, mapping. You know, I play around with it here, but if I had more time, this is an ongoing thing. I could make a map from the station to here. So again, it's a new frontier. It's spatial computing. So basically, whatever you can do on a computer, you can do in space. The question is, what is gained by doing it in space? Or what is the advantage of doing it in space?
Sorry, where?
There you are. So thank you for your very interesting talk. Like, it was very nice to see about. So my question is, like, how often do you work closely with like some of the startups like which are coming in like for AR based hardware manufacturing? Because like there are like some good developments in the display technologies, like integrated glasses, or like some short through projector, holograms, even holograph systems.
Thank you very much. Really, thank you very much. It's only in the past 6 months that I've had an epiphany where I really don't want to be associated with them so much. Not that I don't like them, but I'll give you an example. In Fukuoka, by chance, I found a man who has, it's called Fruits Planet. And we just started talking, and I did a little demo in his place. And now I'm doing it in his place because with fruit, not every day, but pretty much once or twice a week, he has new fruit. So we're experimenting with him sending me a picture of the fruit, and with the QR code, anybody can see that. So my point being that lobbies, small shops, places like that, I'm much more interested in them than the startups because, again, once you start talking about goggles, I'm happy. I'm the happiest guy, not the happiest guy in the world, but when Apple said that they were going to do the Vision Pro, great. Why? Because it increases awareness. But again, it's another piece of equipment that a lot of people aren't going to have. Everybody on Earth has a phone right now. So I'm more interested in connecting with them than the people who have the Apple Vision Pro. However, I'm also making a project with medium format digital photography that I would really like to make a piece of content for the Apple Vision Pro. They're beautiful, but I'm a one-man show, and unless they come up to me and say, hey, Steve, can you make some content, there's no advantage to me to seek them out. But thank you. I mean, it's only been in the past 6 months that I realized I was going to all kinds of startup stuff, New York Tech Week, blah, blah, blah. But unless they're going to fund me, there's no incentive for me to seek them out.
Oh, like, yeah, that makes sense.
I don't mean to sound arrogant, but
no.
But like hotel lobbies, movie lobbies, those are the kind of people, bakeries, Eventually, when people understand, see, I need to make the Maith logo into a QR code that's distinctive. And then anybody that knows that, recognizes that QR code, knows, oh, it's something made by Maith. So it's one day at a time. That's not going to happen tomorrow. Now I'm just happy to share experiences.
Yeah, thank you.
I'll grab that on my way. Oh, thank you. Anyone else while I've got the other mic?
Thanks a lot. I wanted to talk about that the incident you talked about in Italy, where you were wondering if they take away the table, what will happen to Bubiko, right?
Right.
So I was wondering, is it possible to actually, associate these characters with an object rather than just a specific 3D location? Is it possible to do that?
Well, just to clarify, I knew what would happen with Bubiko is that if she thought the table was going to be here and the table was over there, that was okay. It's okay, but her path is fixed. So again, location-based AR means you're linking the content to a location. So that's one of the challenges. Glass is a challenge. Another thing is if I scan that back wall and I make that painting the centerpiece, and then next week they put in a different painting, it's going to confuse the computer. So that's another consideration. That's why I like that rock wall. It's solid, it's contrast, and it's not going to move. So
yeah, that's why my question, like, is it possible to associate it with the object rather than the location?
I'm experimenting with that. I had a 21-day pass for Japan, and I've been all over. It expires on Sunday, so it's all a blur. I think I was in. Yes, I was in Utsunomiya this morning, and they have a character that is half dog, half gyoza, and we've been talking about some stuff at using AR to promote it. Now the exciting thing is that half dog, half gyoza will be in Shibuya near Hachiko at some point. Okay. So the hope, and we'll test it, and it should work, and it's related to your question, is that when we attach content to that dog in Utsunomiya, it should be there whether it's in Paris or Shibuya. Okay. But it's a test. It should work, but until you do it, you don't want to say it's 100%. Okay.
Good luck for that.
Thank you.
Hey, over here.
Oh, yeah, sorry.
Thank you for the talk. So what's the legality on AR right now? Like with the Macy's parade, do you have to get permission to
Wow.
do the bagel?
Wow. That is a brilliant question, and it's something that I'm concerned. No one's going to care until there's money involved, for one thing. Okay. Secondly, I try to find places that hopefully they're owned by the people that I'm speaking to. But yeah, there's an interesting artwork. I don't know if you know Jeff Koons, but Jeff Koons did something. He's the guy that does the balloon dogs, and he did, with Instagram, of course, $1 billion budget or whatever. He put them in Sydney Harbor. He put them in Paris. He put them in Central Park. And a guy, I wish I could remember his name because it's a brilliant piece, but he made an exact copy of the balloon dog and put it in Central Park, but he covered it with graffiti. And his point was, who gives who the right to put stuff in a public place? So it's a good question, and again, once money starts to get involved, there will be some answers. But for now, I'm concerned about it. But most of the stuff, all the stuff I've done, there's been no money. So.
All right. Thank you. Thank you.
Okay. Any more questions? I have one. You keep talking about no money, no money, no money. As an artist, as an artist,
not happily.
as an artist, I understand. So my question is, like, you've traveled all over the world. How are you funded?
I was unloading trucks at Amazon for 3 years. I've done this and I've done that. That's it. I mean, it's not. There's no trust fund or anything like that. I mean, it's been pretty tough.
So when you get invited to the other countries, you're paying your own way, or
Yep.
Wow.
View conference. I mean, for me, it's again, everybody else is like Star Wars, Game of Thrones, Hollywood level quality. And for me, networking is an important thing. I met a lot of people. One of the things that I was hoping would happen sooner is that AR would become more streamlined. Right now, with the system I'm using now, all you need is a QR code. Before, when it was an app, it's been, from the word go, high risk, high return. I mean, when it happens, I'll have a network all over the world, and things should be okay. But when you got to deal with an app, it's just you either say I'm not going to do this at all, or you say I'm going to wait until this app hurdle, until they overcome this hurdle. So that's starting to happen as of basically this year. So I'm ready for this year. I've got 5 pilot programs happening in Detroit right now. So when I get back, I'll see what the results are. But it's a frontier. So, but again, I think I'm one of the first ones out. So see what happens.
So if, oh, do you have a question? Yes, but you can. No. It's better to have someone who's not involved to have a, yeah, there you go. I've already had my question.
So I'm interested to know, where do you see the sources of revenue in the future? Do you see it as being used? So you mentioned education tools and things, but do you see it used as things like advertising
Yes.
or other kinds of promotion?
Yes.
Is that really the pipeline? Also, the pipeline you're interested in as well?
Different topic, same topic. The word augment means to add to or to improve. I can't see, at this point in my life, I can't see myself doing something for something I don't believe in. I mean, you know, not every big company is bad. If a big company wants to talk to me, fine, but you know, I haven't been seeking them out. So yeah, I think there will be some steady revenue. The other thing is that, imagine I have 100 locations, places that I like, trust, you know, organic or whatever as positive as possible. Once this, there would be a scanning charge, and that might even be free. But in order to renew their content, that would be a subscription, and that would be a revenue stream. So, you know, there is some money on the horizon, but tomorrow, next year, I don't know. But yeah, I'm not that altruistic that I don't care about money. The other thing with Bubiko was that I wanted people's first connection, even if very remotely, with AR to be something positive and not a zombie, not a shooter, not, you know, something like that. So I give out these stickers, and I hope everyone gets a sticker before I leave. There's no website or anything on there. And in the AR world, she is kind of known. I mean, I wrote that thing about Superstar. You know, some people know her, some people don't, but only in the AR world. Having said that, this trip I was very, very fortunate to work with a group called Digital Art Center, and there's about 6 or 7 of them in Japan, and it's a government agency committed to helping people that have withdrawn from society to re-enter society using animation and anime and stuff like that. Really a stroke of luck to meet with them, and they came up with this design. We've got postcards, we've got some badges and stuff there that I guess I should mention, you know, exit through the gift shop, or, you know, there's some stuff over there, but you know, that was just a really amazing thing. So in fact, I have to go back to Nagoya and conclude that they want to make some sort of anime or some sort of booklet. It always goes through the Japanese translation, so I'm not sure exactly what they want to make, but we have to have a meeting about making some sort of publication type thing.
Okay, so that's all we've got time for that. Thank you so much, Steve. Sorry we kept cutting you off.
No.
But big round of applause for Steve. And let me just switch back over to the house slides and grab my clicker for that. Boop. And boop. Okay, we're good. So yeah, Bruce, aka American Andrew, wanted to have a few words with us. Just him and you. He'll be here in a second. You're okay using this mic, right? We don't need to strap you up to the cybernetic enhancement.
I'll have this mic in one hand and the clicker in the other.
Yeah, there you go.
Is the okay one?
Yeah, you do go right.
Yep. All right. Hello and good evening, and I am American Andrew. Thank you, Canadian Andrew. Speaking of Americans, we were thinking about charging 1,200 yen for Americans to enter tonight, but decided against it. Is the slide working, or are we just on the?
It's on black right now, so you should click ahead. Down button. No, it should be right. Oh, it's okay. Oh, wait. Huh? Right, there we go.
Okay, so we'll get back to the augmented reality in a minute. I knew it. Okay, we'll get back to augmented reality in a minute, but I do want to take a slight detour into reality for a moment, if you'll indulge me. So the last time that I spoke, thankfully you can't read all of these, but in February, I mentioned the increasing lists of words that you cannot use if you want to get funding or attention from the federal government in the U.S. Now, I can't read these either, really, but all the words that you would expect to be up here are up here. This particular list came from PEN, which is a writers' freedom network in the U.S. And I just want to repeat again, if you happen to be an expert in any of these topics, whether it's climate change or LGBTQ rights or promoting diversity or any other number of things that are here, please talk to me. We would like to have you as a speaker. So moving on, I wanted to highlight a couple of things that are happening. Many of us in the room are involved in research or in science. I wanted to repeat a few things that may have been bubbling just under the headlines in the last few weeks due to things like tariffs and some other things I won't be talking about, like so we say the abrogation of due process in the U.S. Yeah, and a lot of other things. You may know that the health agencies in the U.S. and health research have been really severely affected. If you're looking for someone who is doing a great job of covering this and you're not familiar with Derek Lowe's work, I highly recommend his blog over at In the Pipeline. Derek Lowe is a fantastic writer. He's been involved in drug discovery for decades, and he is angry, as am I. Next slide. Okay, this is the older version of the slides. There was a third headline at the bottom, I think. But anyway, it's all right. So you may have also heard this week that there is a showdown happening between Harvard University and the administration. If you have not seen the lists of demands that the Trump administration made of Harvard, I suggest looking through them. You can find them through Harvard's website. The nicest one on the list is a total ban on masks on campus. It goes on from there, demands that the government essentially be able to govern the university and ensure equality of points of view in the different departments. Harvard's rebuttal is worth reading, as well as a discussion around it. You may have heard just yesterday that the administration is now threatening to, how can I put it, revoke their right to have foreign students at all. Next slide. Meanwhile, around the country, at a lot of different universities, there are being a lot of student visas are being revoked. The reason that I brought up Johns Hopkins specifically is because I used to have a summer job about 20 years ago in the Hopkins Office of International Students. That is the office that is responsible for handling visas for all students and workers essentially at the university. And I don't know the people who work there now, but I did know the people who worked there 20 years ago. Many of them had started just before 9/11 or just after. They got into the job because they loved working with international students, helping them build that community. And they found themselves after 9/11 increasingly working as immigration lawyers without law degrees. As the law got more complex, the backlogs got longer. I remember around 2005, I had the chance to go to a conference for professionals in this area, and I was shocked to learn how many months it took to simply get a student visa in the US. I can't imagine what it's like now to be working in a department like this and to wake up and look into the CVIS system, which I remember working in, and basically looking, just trying to figure out whose visas have been revoked. And they haven't been given any reason as to why. They can't determine any pattern. So I'm angry, but next slide. I think Matt Blaze has said it best. If you don't know who Matt Blaze is, he is one of the world's foremost experts on election security. He's a professor at Georgetown University. Okay, next slide. So what can we do about this? Some are louder than others. Naturally, the French university is probably the loudest. There are programs happening to try and welcome researchers who are being driven out of the U.S. or afraid to remain in the U.S. The most high profile is probably the one at this university in Marseille in France. There was also an article recently in Science talking about this with the more realistic note that budgeting and funding is, not increasing worldwide at the moment in a lot of places. So there is most likely going to be quite a lot of brain drain from the US. So what can we do about this? First of all, if you're working here in the sciences, I hope that you will try to make wherever you're working a more welcoming place for folks who want to leave the US. If there's anything you can do about this or to influence, I hope you will. Next slide. But I've been sitting here and I've been trying to think about how to put this for the whole week, really. And I'm American, of course. I've been living in Japan for 6 years now. I'm kind of lucky. I do work in research, but I don't have a lot of reason to travel. That's not a big part of my career. And I also happen to work in a field that hasn't been directly affected by a lot of this. The field that I work in is funded through agencies that haven't been cut very much in the US, is not questioned by the current administration. And I think that's going to be the case for a lot of people, right? And there's an argument to be made, well, if we just kind of keep our heads down and suffer through this in a few years and we take the long-term view, that everything will be all right and we'll get by. But I kind of think that we have to take a short-term view on this, or there might not be a long-term. So what I'm asking is that you think of some way that, especially if you work with people in the US in some way, that you can make this not to be business as usual. If you're in the habit of going to conferences in the US frequently, you should try to avoid that. You should stop going, and you should try to tell people, the conference organizers, your superiors at your universities, why. If you work with other groups or you have collaborations in the US, you should be discussing these issues and what you're going to do about them, even if you're not worried about it. I personally, look at me, right? I'm not terribly worried about what's going to happen to me if I try to return to the US. But if I say I'm not going to, that makes a difference. And if one person in this room listens to me and makes a change, and then maybe tells 50 other people this, and one of them tells someone in the US this, and they make a decision differently because of that, I think that's important. So I know it's difficult. I know a lot of people's careers involve collaboration with the US. It is, it has been the global hub of science and business in a lot of areas for decades. But I hope you will consider the value of a career that doesn't match your conscience. And I think that's all I have to say. I wanted to end with a quote from a brilliant Canadian thinker, but I don't know a whole lot about Canadians, so next slide. Instead, I chose red green. Okay, that was maybe a little bit too nerdy for everyone, but just keep your stick on the ice, and remember, we're all in this. I'm pulling for you. We're all in this together. I can't do the voice. You want to do the voice?
Stick on the ice. Yeah, that's the voice.
Okay. And that's all I have. We'll be open for the rest of the evening. Please do try out the AR. It's pretty cool over here in the corner. Yes, I have a question. Oh, microphone.
Yeah, just wanted to say thank you for that. And since you mentioned funding, for researchers who are leaving the US, I've been in Japan 20 years, and for 1 year I worked in Paris as a visiting professor 10 years ago, but for the past 6 years I've been working for the EU, promoting Horizon Europe projects and funding. So the EU is actually opening extra funds for US researchers who are actually hoping to find a foothold in Europe. So if you know anyone looking for money, funding, I do recommend that you look into the Horizon Europe program. And by the way, for Japanese colleagues, we are about to sign the, hopefully, we are about to conclude, I should say, the association agreements this year with Japan to Horizon Europe. That's for Pillar 2, different types of projects and clusters. So if you're hoping to collaborate with Europe, receive money, if you're working at Japanese institutions, that's a really great option. Yeah, thank you.
Oh, lovely. Thank you for that. And I really hope that we start seeing something similar in Japan, but we'll see. Okay.
So, so thank you for that not depressing at all thing you just did. And really, seriously, Marshall McLuhan, Leonard Cohen, and you pick red green. Sorry, Canadian deep cut.
Canadian deep cut, indeed.
Yeah, we're all about deep cuts. So should we move? Are you ready to move to the thank you slide, or?
Yeah, I would say just please don't look away.
Turn the music down a bit.
Yeah, I would say just please don't look away. It's really easy to. Please don't doom scroll either. Like, take care of yourselves, but please keep paying attention and talking about what's happening. And that's it. And back to augmented reality.
And now we sing a duets. A whole new world. Yeah. Let me just. Can I do the? I'll do the thank yous. Yeah. So I want to thank Andrew, Bruce, Todd, the man behind the scenes who make sure we get speakers booked, without which this show could not happen. Melvin, the man on the cameras. Daria, the woman on the music and the sound, and make sure we get heard. Gray running the socials tonight, I guess. No, I don't know. What would we call that? I don't know. Gray just being Gray. Travis on the stream. Salinas. What am I saying? I'm getting tired. Selena at the door. I've been up since like 5 a.m. And Lucille, who's had to leave already because she's going for a hike at like 5:30 in the morning or something insane like that. Who helped me carry a bunch of crap in today. Did I miss anyone? I hope. Anuj for being Anuj. Hi Anuj, how you doing? All right, and big thanks to our venue, Yozan Park Lounge. We're running a little overtime. We're supposed to be out of here by 10:30, but if the bar's still open, buy a drink, make them happy. If not, we might start shooing you out of here in like 15 minutes. But until then, thank you so much for coming. So great to see new faces, so great to see familiar faces, and see you hopefully next time, May 23rd. Bye now.